All right, hello geometors. We're going to take this from page 17 today, and let's write the date at the top of that page so we know when we started. Again, the top of 17. So isosceles triangles. Let's sketch one here, which is already sketched for us, and just remember what it means to be isosceles from the day that we did definitions last week. An isosceles triangle has two sides that are identical. And you can make, similar markings to show that. If you had one marking and one marking, then they're twins. If you have two markings and two markings, then they're twins. They're the same. But something else you get, a bonus with an isosceles triangle, is that their base angles are also the same. So as soon as the angles are the same down here, then the sides are the same. Vice versa, if the sides are the same, then those base angles are the same. So isosceles really means angles and sides. Two angles, two sides are the same. And then we call this other angle, the one that we haven't talked about yet, that has a name called the vertex angle, which is the angle that isn't like the other two. So let's look at this example here, number 12. If 98 degrees is at the top, and these two sides are the same, then find the measure of angle. It wants angle C down here. So what is angle C? Well, angle C is going to be the same thing as angle B, but it wants us to answer angle C. So what I'm going to say is I had 180 degrees to spend. I spent 98 of those degrees on the top vertex angle. That leaves me with 82 degrees. And since these two are identical, I can just say, well, I'm going to split those in half so they're exactly the same. So each one of those is 41 degrees, which makes angle C 41 degrees. So when you're given the vertex angle, subtract it from 180, divide by 2, and you have the other two base angles. Question B is actually below it, so we'll do that one first. Now, this is a little bit different. Notice this time it gives you the isosceles triangle here, and it gives you a base angle, whereas on the first question we did, it gave you the vertex angle. So you might even think this is easier, because if this is 78, the other base angle has to be identical. So that's 78. So far, I have spent how many angle degrees? Let's see. 156. So what's left for the top angle? I only have 24 degrees remaining for that top angle. So angle A is 24 degrees. Back up to the top one here, question C, just like the last one we did. We know that these two are base angles because these are the two sides that are congruent. So unofficially, you could almost call that like the top of the triangle. Okay. So if that's 65, then so is that. So that means so far, I've used 130 degrees. I'm only allowed 180. I take away the 130 I've already used. That leaves me with just 50 degrees for angle A. But if you notice, I liked that I went through and did that, but I didn't even need to because it simply asked for angle C, which I knew right off the bat because it was the twin of angle B. But it wasn't a bad practice to go through and find angle A anyway. Question D. Oh, we got a double whammy here. So there's really two different questions, two different triangles, I should say. It wants us ultimately to find angle D down here. We know nothing about this triangle, right? So let's focus on this triangle first. And I know you can't do this easily anyway, but let's pretend you don't even see that. So if that's the case, we can work through this first triangle. 180 degrees minus the vertex angle at the top leaves us with 144. But remember this one, when I knew the vertex angle at the top, I took the remainder and divided it by 2 to split it evenly. So I'm going to take this 144, divide it by 2, and you get 72. So that means that both of these angles down here are 72. All right. Now let's focus on that again. This other triangle is sort of upside down. This is the top, and that is the bottom, if you want to think about it that way. So I have a linear pair right here. So I can figure out this angle by subtracting it from 180, which makes this one 108. So just like I focused on one triangle before, I'm going to do the same thing this time. Let's pretend this doesn't even exist and only worry about the other one. If this triangle, that was kind of scary, if this triangle has used 108 at the top, and I take that away from 180, that leaves me with 72 degrees that I have to split evenly among those two corners, those two base angles. So half of 72, you may know, is just 36, which means both of those angles are 36. And it wanted us to tell them what angle D was, and we just did. But that was definitely an involved problem because you had to start with this triangle and work your way through it. On page 18, we're going to only focus on the ones I highlighted in pink there. So question 1D, I'll have you do this one on your own. It gave you that these two sides were identical, and it gave you the vertex angle of 118. It wants you to tell what angle A was. But remember, angle A and angle C are the same. So just to double check the work on that now that you've done it. We had 180. We took away 118 at the top. That left us with 62. Meaning we had to split that evenly, so each one of those was 31 degrees, which makes angle A 31 degrees. Now we'll move over to number 2B in the middle here. Another double whammy like the one we did on the last page. We're going to start by just focusing on this triangle on the left. If we have a vertex angle of 64 degrees, that leaves us with 116 degrees to split evenly here and here. So that 116 became two little parts, two twins of 58. Now I'll have you finish it, and there's your hint. So you're going to find angles 2 and 3. And to check your work, we have a linear pair right here. 180 minus 58 is 122 degrees. So that angle 2 right there, linear pair, is 122. And angle 3 is going to be a base angle of this triangle, this green triangle here. We know that the vertex angle, remember, if I Pretend that this isn't here. It might be easier to see. So treat this like the top and this like the bottom. If this is 122, what does that leave me? 58 degrees. And if I split 58 degrees in half, I get 29. So the base angles are both 29, which means angle 3 was 29. And the last one I'll have you do involves some algebra. You have three angles labeled here. You have a 68, you have a 3x minus 3, and you have a 2x. So three different angles, but you know that every triangle has interior angles that add up to 180. So you are going to solve for x here. Here's your hint. You're adding three pieces together and solving for x. And to check your work, let's combine like terms on the left side of the equation. We have 5x's, right? 2x plus 3x. And then we have 68 and a negative 3, which would be a positive 65. And then we solve a simple two-step equation from there. Five x equals 115. Divide both sides by 5, and x is going to be 23. That's it. Don't worry about that word upload at the bottom. That was a note to myself. You are finished with that Ed puzzle.